We have one more function operation in this section, and it's called the composition of two functions, or the composition of functions. And this actually uses a new symbol that you guys wouldn't have seen before. And that symbol is written right over here in this little red equation. It's the same thing as the last video. The red and the blue mean the exact same thing. It's just kind of a preference of which one you like better. This little open circle symbol does not mean multiplication. It's like a new symbol. It's like a small open circle. It actually basically, in my opinion, stands for the word of. So you would pronounce this f of g of x, which I have written down right here. I prefer to write this in the blue way because I think it makes more sense. This still means f of g of x. So I like the blue a lot better. And when you're doing these problems, you're essentially going to get one answer and plug it into the other problem. And you're going to always start by doing the inside. I'll show you what that means through example. So I gave you an f of x right here and a g of x for our equations. And I ask you to find f of g of 4. That's what this means. So first thing I'm going to do is rewrite it as f of g of 4, because this is kind of a more natural way of putting it. So you always are going to do the inside part first. We need to figure out what g of 4 is equal to. So we're going to go over to the g equation right here, and we're going to plug in a 4. So we do 5 times 4 minus 8. It turns out off on the side that we find out g of 4 is equal to 12. So we plug in a 4, we get out a 12. That means this whole inside guy is really just 12. So they really are asking us to find f of 12. So we got that answer. Now we're going to go over to the f equation, and we're going to plug in a 12 and see what we can get out. So we're going to do 3 times 12 plus 4, and we're going to get out 40 when we do that. So f of g of 4 is equal to 40. You plug the inside part, you get that answer. Then we go get this 12, we plug it in right there. 3 times 12 plus 4 equals 40 for our final answer. So for the second one, it's the same number, but the order is changed. So let's see if that actually makes a difference here. This would be g of f of 4. And we want to do the inside part first. You always do the inside first. So we're going to figure out what f of 4 is equal to. So this time we're going to the f equation. We're going to plug in a 4 right there. 3 times 4 is 12 plus 4 gets us out a 16. So f of 4 is equal to 16. That means we're going to really be doing g of 16. So we're going to go over to the g equation right now, and we're going to plug a 16 in for x. And when you plug that in, we're going to get out a 72. So you go and you plug in 5 times 16 minus 8, you're going to get 72. So the thing I want to point out with these two examples here, the order you put these in very much matters. We plugged in the same number, but depending on the order you have to do it in, we got two different answers right here. So be careful with the order they have it. You do the inside, you get your answer, you plug it in the other one. For the last problem of the video, I want to do one example where there's an x left in here, because it's a little bit trickier than your average problem. When you're looking for f of g of x, we're going to rewrite it first off. And we always want to do the inside first. The issue is the inside isn't an actual number on this problem. It's g of x. We can't go plugging anything in. So what we're going to do is take the actual equation for g of x and replace it right there. So g of x is 5x minus 8. So what I'm going to do, this is really f of 5x minus 8. If you can't get a number by plugging it in, just drag down the actual equation and put it there. So that's what g of x is. So now we have to find f of 5x minus 8. So when we do that, we use the f equation. This guy right here is what gets put in for my variable. So my thing right here is going to get plugged into the f equation for the variable. So it's kind of, I got lines going all over the place right now, but hopefully it kind of makes sense. What we're going to do here, if we were plugging in a 5, we would put a little 5 in parentheses, but we're plugging in 5x minus 8. So all of that goes in the parentheses for the variable where we plug it in. And then there's still that plus 4 from the equation right here. So we just plug the whole 5x minus 8 right in for that x. That x goes away, turns into that. And then we just distribute. We get 15x minus 24, and then the plus 4. So it turns out that our new equation here is going to be 15x minus 20. Composing functions when you still have a variable in them is a little bit tricky, so that last example may be a little fuzzy, but we'll practice that some more in class.